Hello everyone, this is Pratik Sibkhan here, currently pursuing BBIS undergraduate program at Kathmandu University. Today we are going to solve a question of partial derivative, but initially we need to know what the partial derivative really is. Let's say, let's say I have u which is equal to the multivariable function like f of xy which has two independent variables. Then, in partial derivative, if we do derivative of f with respect to x, it only cares about movement in x direction. That is, x seems to be variable and y must be constant throughout the process. And same goes while doing derivative of f with respect to y. With respect to y, then we must keep x constant and y should be variable. Therefore, we can say derivative of u with respect to x keeping y constant is known as partial derivative of u with respect to x. Uh, Similarly, we can write it also as write it also here uh, like this form ux comma delta u by delta x comma f delta f by delta x comma f of x like this. So, same goes for other higher orders, which we can obtain by doing partial derivative of x and y with respect to x and y or y and x. Like this is so this is shown here. That is delta by delta x, and derivative of delta u by delta x can be obtained by derivating delta u by delta x with respect to delta u by delta x keeping y constant. Here it is presented like that. And other higher orders can also be done by the same process. Now let's move towards the question. Here is a question of partial derivative which I am going to discuss today with you. Question is to find the first and second partial derivative of x cube plus y cube minus 3axy. So moving into the solution, to determine delta u by delta x, we have to find the partial derivative of u with respect to x, where u is function of x and y. So let's differentiating u partially with respect to x. Here the first terms contains variable of x. So solving it, we get 3x square, and in second 3x square, and in second term we have constant term y, so it remain as it is, and in third term differentiating partially we get 3ay. Similarly for delta u by delta y, differentiating u partially with respect to y, we keep x constant which remain as it is, and we solve for variable term y, we get 3y square minus 3ax. Now, we have already learned how to take the partial derivative of u with respect to x and y. Let's see how to take the higher order partial derivative for the same question. We solve delta square delta square u by delta x square. We have already taken the first order derivative. We will write down that here. Now differentiating again partially with respect to x, remember the terms of y are to be taken as constant. Then derivative of 3x square will be 6x, and 3ay will be 0 as there is no any variable term. Same goes for uh, delta square u by delta y square, like here. We solve keeping x as constant. Keeping x as constant, we get 6y as a result. Moving forward, we have to find delta square u by delta yx. This means first we have to differentiate u partially with respect to x, which we did earlier, and whatever the answer we get, we differentiate that answer partially with respect to y, uh, treating as constant. Treating as constant, that is 3y square will be 0 and 3ax will be 3a, because there is no variable term in 3y square. So delta square u by delta y delta x will be minus 3a. Similarly, we have to find delta square u by delta xy. Same process like the previous one goes for this also. We have to differentiate u with respect to y this time. And whatever the answer we get, we differentiate that answer uh, partially with respect to x, keeping y term constant for this time, where 3x square will be 0, 3ay will be 3a, so the final result will be minus 3a, like the previous one. This is also minus 3a as well. So this is how we solve these kind of problems of partial derivative. Hope you got the point. Thank you, until next time.